So let's go with infinity here because there were a lot of issues, a lot of comments on that. Okay.
Just the word infinity, or what?
Well, both. It's like infinite, infinity, whether space is infinite, universe is infinite. These kinds of issues. People, we're relating all this to the universe, to physics, right? And not really to numbers. Like we're not asking, are there infinite numbers? That doesn't concern us as much, even though it's a part of the topic. But the main issue is physics. Is the universe infinite? Is space infinite? What do we mean by that? These kinds of things. Okay, so I'm going to give you here my rundown, my summary of my version, okay, first. Okay, and then he's going to come in here and give his version, okay? So let me go with my version here. And this is a summary. Universe is infinite is an irrational proposal. Space is infinite is also an irrational proposal. Language is of the essence. You need to have the language straight. And what we don't have today is the language straight. People are not talking physics talk, what I call it, right? You have to talk physics. And people bring words of ordinary speech, notions of ordinary speech, definitions of ordinary speech, and they introduce them indiscriminately into physics. And most of my argument is going to be about language. It's about the fact that mathematicians, primarily people who call themselves mathematical physicists, they introduce words of ordinary speech, vague notions of ordinary speech. They introduce them and they try to do science. They try to do physics. That's where the problem starts. Okay, so a lot of the problem has to do with using words of ordinary speech in a scientific context. And specifically, they conflate adjectives with adverbs, okay, and we're going to look at that in a second. They treat motion as a thing, okay, or they explain it. They justify the infinity or whatever of a thing by talking about motion, about traveling, okay, and that's irrational. Mathematical physics, it deals with the motion of concepts. That's what an equation is. Equation only is a description of motion, okay? And so they never found a need to define the word object. What is a thing? And they don't use objects in mathematical physics at all. They use concepts and they start moving them around. They do all their physical interpretations with concepts, and that is irrational. You cannot do that in science. That's, in general, my argument today, okay? And Hans is going to represent, I don't know exactly all his arguments. We'll find out, okay? I'm just going to start with an example, okay? And I mentioned this example in the past, in fact, last week. And it's about Stephen Hawking, what he says in his book, A Brief History of Time. And this gives you an idea of how the mathematical physicists present their explanation, their physical interpretations to a wider audience, in other words, to the public, okay, to the general public. And that's very misleading because they have a total misconception of how this universe works. But people have a lot of trust in these people and say, oh, they know all this math, they must know what they're doing, all the technology that we've developed, they must be right. And so people start believing the physical interpretation, they take them literally, of what these mathematical physicists are proposing out there. That's where the danger is. Mathematical physics and physicists, right? They only have irrational explanation. They only have irrational physical interpretations for any phenomena involving invisible, intangible mediators, such as, the mediator of light, the mediator of gravity, all that stuff. They only have irrational explanations. People don't understand that out there. In fact, even mathematical physicists don't understand it out there. And that's what we're attacking here. So here we have Stephen Hawking, okay, and this is what he says about infinity. The universe is not infinite in space, but neither does space have any boundary. What the hell does that mean? He's got a contradiction in that sentence. I mean, if it's infinite in space, meaning an object, he's treating space as a physical object, he's saying the object is infinite, but then he says it doesn't have a boundary. What is he referring to? Well, he's going to use the word bound and the word infinite or finite, right, in different contexts. That's the problem. He's using finite when he's describing an object. He's saying, space, if you treat it as a physical object, is finite. But you can run, unboundedly around it without finding a bound, a fence, or whatever you want to call it. So in one case he's talking about an object, and the other one he's talking about motion, verb. One case it's a noun, the other instance is a verb. And he's using his language wrong. And that's why we're going to be tackling this language notion that mathematical physicists use, okay? You can talk about finite, as far as this is my version again, finite when you talk about objects. And you can talk about incessantly, right? You can use an adverb, what we call an adverb in physics, not in ordinary speech, but in physics, a qualifier of motion, right? And you would have to use incessantly. You cannot say unboundedly or infinitely. If you're going to talk motion, you use words like incessantly, perpetually, eternally. Those are the words you would use, or constantly. But when you talk about objects, you have to use finite. You use end, like endless or end, limit, limitless, or bound and boundedless, that kind of word. So we're going to use words such as finite, bound, limit, and end for objects. And we're going to use other words called adverbs, such as incessant, perpetual, and words of that nature, which are adjectives in ordinary speech, but they are adverbs for the purposes of physics because they modify they modify motion. Okay, so that's the issue. And here we're saying that Hawking is conflating objects with motion. He's justifying finiteness with motion. That's essentially what it is, and you can't do that in physics. That's the argument here. Okay, so and by the way, he says that you won't find a boundary. But see, that's wrong too, or irrational as well, because see that little man that's going around? Well, he's at some point coming back to the same atom where he started. He's coming back to the starting point. And here I've illustrated that. Here you'll see it, okay? Little man goes around, okay? And he's going to come back to the same starting line and finish line are the same. He's going to come back to the same atom, okay? So he can run all incessantly around, but that doesn't make the earth, in this case, right, unboundedly or infinitely. What's infinite or unboundedly, if we want to use those words, is motion. He's talking about incessant motion around a ball. He's not saying that the ball is infinite because he can run around it eternally. That's the problem. The problem, he's using his language wrong. That's my argument. Okay, and so here, let me just summarize it here, okay? Adjectives versus adverbs. Here you'll see it. What I'm saying is the following. You have to talk physics. If you're going to do physics, you have to talk physics. You can't talk ordinary speech, okay? Now, I put on the left adjectives and on the right adverbs. What are the adjectives? The adjectives are finite, infinite, endless, unending, bound, boundless, etc., limit, and limitless. Those are the words that we're going to use to describe objects. Okay. Now, you may not agree with me. You may say, I don't like those words. I like the word X or like the word Y or Z. Fine, no problem. What I'm saying is, let's by convention, just so we separate the objects from the verbs. Okay. Let's use the words on the left for objects. Okay, so arbitrarily, I can say that let's just agree to use those words for objects so that we separate objects from motion, description of objects from description of motion. The ones on the left, on the right, the adverbs there, we're going to use those for motion. We're going to say incessant, constant, perpetual. We call them adverbs. And you say, but those are adjectives, Bill. Yeah, I know they're adjectives in ordinary speech. You can't say incessant table, meaning that the table is, forever. No, incessant means motion, and constant means motion, perpetual means motion. So we just want to use these words in a consistent way so we can use the ones on the left for objects, the ones on the right for motion, okay? And then I have a couple more examples of where the language is all screwed up. They use the word continuous, like continuous motion. That's irrational in physics. You may disagree with me, so let's just be used by convention that you're going to use continuous for a table. You can say the table is made of a single piece. That's a continuous table. Okay, that's what we mean by continuous in physics. If you want to talk about motion, you use words like relentless or any synonym thereof. Okay, same with straight. A table may be straight. You can't say the table is rectilinear because rectilinear refers to motion. So we want to separate these words. Use straight for objects and rectilinear for motion. And there you have again the big one for relativity, where they use bent, warped, and bowed when they really mean deflected or swerved or whatever, any synonym thereof. In other words, you can't say that light, which is, they simulate it with a bunch of particles, curves around space. No, it doesn't curve, because curve is used for, you can say a hammock is curved, a bandana is curved. You can't say that motion is curved. You're gonna say that the photon was deflected or it swerved or anything along those lines. If you're gonna talk about motion, use an adverb, meaning not the adverb of ordinary speech, but what it is as an adverb in physics. In physics, anything related to motion, description of motion, we'll call an adverb. Okay, so you can't use words like bent, warped, or bowed to talk about, the warpage of space-time if space-time is not a physical object. If you're gonna justify it with motion and say, oh, the photon was deflected by gravity or by whatever, by mass or whatever you want to deflect it with. Okay, the photon was deflected. It was not bent, okay, or warped. Okay, so the issue here is language. A lot of it has to do with the irrational language that mathematical physics uses to convey their physical interpretations. And so finally here, let me give you the conclusion. This is my conclusion again. I don't know what Isaac's going to say here. I can't read his mind yet. It's irrational to say space is infinite or the universe is infinite. Why? Infinite is an irrational term. Okay, we're going to use finite or infinite only for objects. Why is infinite an irrational term in that context? Because adjectives only qualify objects, right? So if you're going to treat space or the universe as an object, you're going to have to qualify it with an adjective. In this case, you can say finite and infinite. What's the problem? No object is infinite. All objects have shape. They're all finite, right? And therefore, you cannot say that an object is infinite. So the word infinite is outlawed from physics. Okay, mathematician, what is that? An individual who doesn't understand the difference between an adverb and an adjective. And now I'll give the microphone to my dear son.
Let me get my baseball bat. Okay, so I have a problem with the statement.
Good. And now,
the statement, adjectives only qualify objects. You see, adjectives, I would split into three categories of adjectives. There are some adjectives that only qualify objects, like you were saying, bandana is curved, bent, warped, or bowed. Okay. Concepts can't be bent.
Good.
So there is a set of adjectives like red, we got long, pointy, we got big. These things only apply to objects. Then we have another category, whole set of adjectives that only apply to concepts. Those are chronological, scalable, far, infinite, finite. Even the word finite cannot be applied to objects because infinite and finite, what we're talking about is counting. There's a countability is essentially what we're talking about. But we're only counting. But infinite only applies to concepts because there's no such thing as infinite objects because they're the
counting or what? The number of objects, meaning finite or infinite.
But since there are only so many atoms in our universe, as we established, there's no such thing as infinite objects in that sense.
Infinite number. I want to put the word number in there. I want to make sure we're talking about counting.
But there's a whole set of adjectives that only apply to concepts. But then where the mathematicians get confused and where they cheat is the third category, which is the set of adjectives that apply to both, which is good, bad, complex, these things, and that's where they use the word infinite for objects, which does not count. That's cheating. There's no such thing as an infinite object. infinite only applies to concepts such as numbers. Numbers are a concept. How many ideas there are in the universe or can be had. That's also infinite because you can always make more.
Counting.
Yeah, it's always
Numbers.
it's always like counting. It's always what infinite really means is you can make another. You can generate another one. Like for example, you can run an infinite amount of times around a track because you're counting a concept, which is running around a track. But you can't say therefore the track is infinite. The track is finite. At some point, you're running over a spot that you already ran over.
Can you say an unbounded number of tables?
What does unbounded mean?
No, I'm saying, can you say that in any context? It doesn't. Is it rational to say
Unbounded
there's an
number of
unbounded? No, but I'm asking.
Yeah, I'm trying.
Can you say we have an unbounded number of tables?
Conceptually, or
Well, any way you want. I mean, can we
can.
say that, or is that irrational?
yeah, I can say
In
there's
physics,
there's
in physics,
Yeah, there's an
unbounded number.
there's an unbounded number of tables that I can generate in my mind conceptually.
You can say that. You can say
Because-
unbounded number of tables,
Well, I can imagine.
or incessant number that I counted.
Yeah, it's more.
Oh, yeah, I know.
That's what infinite
And this
means.
is the issue.
Essentially, you can always generate another one, but if you're generating them out of thin air, that means they only apply to concepts. They cannot
Yeah,
apply.
but
to
I'm saying,
objects.
and again, I want to emphasize that because I'm saying that finite, limit, end, any of those three words, right? Like endless, limitless, or unlimited, or any of those combinations, right? Is the same thing as finite and infinite. In other words, those words, end, limit, finite, and what's the other one?
Bounded.
Bound. All those four words refer to objects.
That's
And-
what I don't
Okay,
get.
hold on, yeah, okay.
Yeah, I got a question.
Okay,
about that.
but I'm saying those we should use only for objects. Whether you agree with me or not, let's do it by convention. I don't care. What I'm saying is, let's separate the motion from the objects. If we're going to talk about objects and saying an object is finite, an object is unlimited or whatever, let's use the words end, finite, limit, and bound. If we're going to talk about motion, then we're going to say incessant, eternal, any words of that nature. So that we separate, so that we keep the ideas straight. And we don't get into the issue of finite but unbounded universe, because finite but unbounded is a contradiction if you're referring to objects. But if one of those refers to motion, well, then we're comparing apples and oranges. That's what I'm saying.
But my question is,
Yeah.
does it make sense to talk about a finite table? That makes no sense.
A finite table.
A
Yeah.
finite table doesn't make sense.
Because
A finite number of tables.
No.
But a finite table
Because
makes sense.
you got that from ordinary speech. Finite.
What
as
does
far
a
as
finite table mean?
Okay, that's what I'm saying. When we're talking about finite and
That's just
hold it,
just
hold
stick
it,
with finite.
hold
Don't
it,
add
hold it,
to
hold
it.
it. No, I'm
Don't
going to
add
add.
to
I'm
it.
going to add. I'm going to add because they're all synonyms. I want to make sure that the concept is there. Finite, end, limit, and bound refer to the end of the table, of end of an object. But so when we say finite table, we're saying the table is bound. The table has ends, has fin in Spanish, fin, right?
But doesn't that
And
mean discrete?
Huh?
Are you talking about discrete, where it's different from other objects? That's what you're
No,
saying.
no, I'm just saying
The
that the
table is
table has
discrete.
ends.
But that's discrete, not finite. Finite only applies to numbers.
And it doesn't. It's the mathematicians who introduced the word finite, infinite, really, to say infinite numbers. No, what you're saying is number. The word number means to count. And what they're saying is incessant counting, and they said infinite numbers because they used an adjective to qualify a noun. That's how it got introduced into physics, or mathematical physics.
Yeah.
And all I'm saying is, let's keep the language straight. You don't have to agree with me on the word. You can call it X or Y or Z. What I'm saying is, let's keep the adjectives that qualify nouns here, and let's keep the adverbs, as I call them, that qualify motion of those nouns over there. Let's separate them. Let's not say finite and unbounded, because that is a contradiction. Because the finite refers to the object, a ball. You can say, this ball is finite.
No, I wouldn't say that.
No, I'm saying what the mathematicians say. They say, look, this ball is finite. Why? Because it ends right, it has a boundary all around. But then they say it's unbounded. You say, what do you mean unbounded? I thought you just said it's finite. Well, it's unbounded. You walk unboundedly around because you don't find a fence. when you walk around it. But now you're talking about motion. Now you're not talking about the object. And that's where the problem comes in. These people are mixing their language or comparing apples and oranges.
I'd say
That's my argument.
when someone says a finite table, what I would understand is the numbers.
No, it's got ends.
Let me finish.
Oh.
The numbers is when you're measuring it, it's got a set number. The length, width, and height are fixed. It doesn't keep going.
Well, why don't you call it incessant then? Why do you use the
You
word
can't say
finite instead of
incessant
incessant?
table also. doesn't
No,
make
incessant
sense.
counting.
No, but
Because you're referring to measuring.
But when you're saying finite table, I'm saying that doesn't make sense because what you're saying is counting. Finite means it's countable. That's what finite I'd say would mean.
No,
but I would
but
take
why
it-
don't you say incessant?
I wouldn't say
if you're
incessant
talking about
either.
counting,
I'm talking about
incessant counting or finite counting. Ceasing counting, stopping counting. Why do you put the word finite in the context of counting when it should be ceaseless or
Because
ceasing?
finite is what I'm saying. Finite and infinite are adjectives that only apply to concepts. They don't apply to objects.
You're the jury.
But I would take it one step further.
Yeah.
Adjectives don't belong in physics.
It's the other way around. Adjectives only belong in
No.
physics. They don't belong in mathematics. Mathematics
But you
only
said
uses adverbs because only mathematics is only a description of
Yeah.
motion.
It's only
So
one.
they should only use adverbs. I don't care if it's an adjective used as an adverb. I don't care. What I'm saying is a qualifier of motion we'll call an adverb. Just let's define it that way. And if you're going to use an adverb to qualify motion, and that's all that mathematics does, an equation is only motion, it's a description of motion,
And all you need
then
is adverbs.
mathematics only has adverb. They should never use an adjective. On the other hand,
Yeah.
physics only deals with objects. You have to have an object.
Yeah.
You can only use an adjective to qualify an object.
But you even said this before. You can do physics without using a single adjective.
Correct.
And you're right.
No. But
You don't
no,
need-
no,
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 you
no.
listen.
Let's
You're
get
not
that
listening.
context right. Let me get that context right.
Yeah.
Okay, that's important too.
Yeah.
There's no such thing as a dead cat.
Thank you.
There's no such thing as a
There
red
we
ball,
go.
okay,
That's
in
right.
physics. There's only a thing called a ball and there's a thing called a cat.
Yeah.
When you put dead, you can't put an adjective because I can't point to you to a
Yeah.
dead cat.
That's what I
Not
mean.
in physics. In physics, you can point to a cat.
In
Whether
fact-
the cat is dead or not, that's a separate issue.
In fact, when I asked, I was chatting with an AI to kind of get some ideas.
Oh,
And when
okay.
I asked it to give me a list of adjectives, the funny thing was almost, I want to say 90 to 99% of them were opinionated adjectives. Long, pointy, big, good, bad. These kind of words don't even
And
belong
left
in
open.
physics.
And
Yeah,
left
but
open-ended, right? Also.
no, but those are bad enough because those don't belong in physics. Who cares if the table's good or bad, red or blue,
Right.
long or short?
In that sense, you were saying.
That's what I mean.
Okay. Yeah.
You could explain every theory or every
With objects,
assumption
without
without any adjectives or adverbs.
Absolutely.
They're
Absolutely.
superfluous in the first place.
Absolutely. And here we'll give some examples of what people do out there, and I think you'll get the hang of why I'm so strong on this language issue. Here it is. Okay, here's one fellow, and he says, "It is impossible to give a complete definition of something with any finite set of words." I like the fact that you use the word finite there, right?
Set of words. What it means is number of words.
Yeah, number, right. It's a-
Finite means number.
Number of words. Because all words can be defined infinitely, right? Again, right?
Number.
Not a single word has an absolutely precise definition. And we say the following. This is the answer to this gentleman. And we say the following. In science, all relevant words must be defined precisely. You must define words precisely. You say, well, I can't define words precisely. And the first thing we have to analyze is word relevant. Whatever makes or breaks your theory, that's what we will call relevant. Relevant is what makes or breaks your theory. That word has to be defined. You have to tell us exactly what you mean by that. And in that sense, we say precisely. Okay, precisely means that the audience understood what you're saying. Okay, and that we'll call precisely.
It's kind of like semantic hygiene.
Yeah,
where
it is.
It's when we're on the same page on something. The only way to know that we're on the same page, it might be a step that's unnecessary. We might already be on the same page. But to be sure we're on the same page, it's a definition issue.
Yeah, and that all people understand the same thing, so
Yeah.
they're all following the same presentation, and we're all on the same page, right?
It's semantic hygiene.
Yeah, and here you have the definition of the word definition. Okay? A limitation placed on the extent or usage of a word. That's what a precise definition is for the purposes of physics. We don't do what this fellow is suggesting, saying, which is the devil's advocate, or runaway devil's advocate says, oh, we can't define words because those words, each word that you use to define a word also needs to be defined, and so on.
Interpretations and so on.
So on. No, that's not the way we do it in science. Okay, that's in ordinary speech. A scientific definition is one that can be used consistently, rationally, scientifically. And here's an example. The golden principle of physics. Okay, what is that? Well, you can't do physics without an object. You need an object. Okay, if we have no objects in the universe, nothing is happening. There is no physics. What are you observing? What experiment can you run? And all that stuff we always talk about. So you need objects. So we define an object as that which has shape. And what does the devil's advocate do? The devil's advocate that takes it to extremes, right? This is extreme devil's advocate. He says, well, Bill, I don't know what you mean by shape. What do you mean by shape? You know, and I say, okay, the first question is there, why didn't you ask me what do I mean by that? Or by which? Or by has? I mean, are those words any easier to define than shape? And so this fellow says we need to define each one of these four words in order to understand the word object. And then whatever words you need to define these four words, you got to define each one of those, and so on infinitely, right? Eternally, incessantly, right? And so this is where the problem is. These people believe that you can't define any word. And here, you want to know what shape is? Very simple. Here it is, okay? You go to the kindergarten and you say, you show them a block, a cube, and a sphere, a ball. And you say to the kindergartners, 5-year-olds, and say, well, these two have the same mass, they have the same color, they have the same everything. And you say, what's the difference between the guy on the left and the guy on the right? And a kindergartner will tell you, it's the shape or form, right? That's what they'll say. The difference is the shape. And that's what shape means. As long as you understood that, we have conveyed the notion of what an object is. An object is that which has shape. And so for people to play around, the devil's advocate to play around and say, well, I don't know what you mean by shape, Bill, this is where the problem is. These people are just playing devil's advocacy for the sake of advocacy.
I can definitely say I've tried to poke holes in that which has shape in it. I haven't succeeded yet.
The way we do it in physics is the following. In science, right? We have 8 billion people inside this room, and the doors are locked. Nobody can leave until we define the word object, because we can't do physics without an object. And you can't say, well, we can't reach an agreement. We don't know what object is. We don't know what shape is. No. We can't open the doors. No one can leave until we define the word object, because you can't do physics without an object.
Well, we can't understand each other's physics if we don't define the word object.
And no one in the last 10,000 years in mathematical physics has defined the word object, because mathematical physics doesn't use objects. Mm-hmm. They do equations, and then they simulate everything with concepts such as field and energy and mass and time and force and so on.
But then they give adjectives that only apply to concepts to these reified concepts.
And the issue is there, people out there, they don't care about equations, they don't care about numbers, they don't care what you measured. They say, well, look, how does this universe work? Meaning, why does it work the way it does? What is the mechanism? What is the mechanism that underlies gravity? What is the mechanism that underlies the quantum jump or whatever?
When you say field, they're none the wiser.
You say it's the energy, it's the field, it's and they're using concepts to represent physical interpretation. That's why people say, well, I didn't understand anything, but I guess I got my shot of science for this week.
It makes me feel smart.
That's
what it is. That's what science videos are. They make you feel smart or make you feel dumb, because you're like, man, there's some smart people out there.
And it's not me, right?
Yeah. But that's what I hate about it all, because it's exclusionary and in a way elitist, because it says, oh, you're too dumb to understand.
Right. And that's one issue. And really, physics is kindergarten stuff. Yeah. Mathematics,
if you can visualize it, you understand it.
Right.
Very simple.
Right. Physics is baby stuff. It's for kindergartners. Mathematics, you need to go to university. If you want to learn calculus and all that stuff, linear algebra, all the stuff I had to take, then you got to go to the university.
And that's fine.
You're learning a language.
but then they go and say you can't understand how the universe works. You can't envision it unless you do math.
No,
those things are
you know what they say?
completely
It's
separate.
even worse. They say we cannot translate our mathematics into ordinary speech, into ordinary language for you to understand. So if you cannot translate, that means mathematics is not the language of physics, because physics is something that a 5-year-old can understand.
No, but notice how mathematical physicists, mainstream physicists, don't come on big podcasts and pull out math.
Yeah, they try to give physical
No one
interpretation.
cares about the math. No one ever, they never pull out a pencil. So this is the equation. We're gonna do it together. They never do that. Weird.
Absolutely. Okay, so here's the universe that mathematical physics proposes: general relativity, etc. Right? These are the three universes: the finite ball, the infinite saddle, and the infinite plane. And out of all these, they chose the infinite plane. They say our measurements show that it's an infinite plane.
Right off the bat, according to what I said earlier, I'd say this is incorrect because finite and infinite only apply to numbers.
Right.
None of these are numbers.
Right.
These are all shapes.
Right. And so there you have the infinite plane. That's the chosen one. I made it finite in one direction only, which is the north side there. But everywhere else you can see it's infinite, to use their term. And the problem is, if it's infinite, in other words, if it's infinite in all four directions, how do you know you're on a plane? You can't get to the other side because you cannot reach a border to turn the corner, do a U-turn and go underneath it. So if you're on top of this, what are you standing on? Are you standing on a cube, maybe? How do you know it's a plane? And so they have the infinite plane, which comes from geometry, which says all planes are infinite, and they say the universe is infinite. That's where they get the notion. But how do they, okay, so that's an object, that's a thing, that's a figure, right? And you say the plane is infinite, and they fixed it with that. It's slash mathematics slash physics all in one. They say the plane is a figure, but we're going to make it infinite, which there's no figure that is infinite, but that's how they start. Yeah. But where's the problem? Here's the problem. Let me show you the problem now. They send this rocket, right? And they say this is how they're going to justify it. This is how they're going to explain it, okay? They're not going to use objects. They're going to use motion. And here it is. They say, look, if you travel...
I love this GIF.
Yeah, here you travel forever through the universe, you're never going to find a wall. You're always going to find more stars, and not the same stars. Very important, because if it's a circle, if it's for example, a donut-shaped universe, well, at some point you're going to come back and see again the same atom where you started. The finish line is going to equal the starting line. But here they're showing it as a plane where you travel infinitely, incessantly, and you always see new matter forever. And that's impossible, because if I live forever, I should be, if God is out there and he's all powerful and all knowing and whatever, if he travels throughout the universe, hopefully he can get out of it. Right? And these people say, no, not even God can get out of it.
There's always more being generated in front of them.
Yeah, and that's what infinitely means in this context. When they say infinite universe, what they're saying is they're creating more stars and more space and more whatever. And forever you can travel, there's more being created. And that's their solution to not answering the question, which is, what is the universe? Is the universe a physical object? Is space a physical object? They say it is, but it's not a finite one. It's a finite one that is growing, and we don't know what's outside of it, because that's an unscientific question, because we have no way of proving it, and blah, blah, blah. Okay, so they just get around the question. If the universe started from a big bang, and it's expanding, hopefully, conceptually, it should be finite. And there should be something outside of it. Yeah. But they say, we can't prove it. I don't care if you can prove it or not.
Conceptually,
it's a done deal. You lost a bet already, right?
It's not that hard.
Okay, so here you have one fellow, and again, these are examples of how people talk and why they're all confused and, they're all irrational. This fellow says, there is no end. There is no outer edge. There is no center. There was no beginning.
Hey, you got one right.
Yeah, but... yeah. And there will never be any end to the cosmos. The cosmos is what? Infinite. So how is he explaining it? He's explaining it with motion. Essentially, he's got this notion of motion, and he's saying, we travel and we can't find an end to it, so I'll call that infinite. Okay, this is where the problem is. They confuse motion with object. if the universe or space or whatever is a thing, it had better be finite. There is no other possibility because all objects are finite. So if you're talking about space, matter, or both, the universe, then it's better be finite, because then you can say, look, it's finite, I can reach the edge, and there's something outside of that edge. If it has no edge, then it's not an object, because all objects have boundaries, edges, or whatever you want to call it. Okay, here you have another fella, and you can see how they're using these words. Mathematically, our universe started from a single point, okay? But it is perfectly possible that it was infinite in expanse.
Expanse.
Okay, so now we're talking about an object. We're saying, look, this object is finite, right? No, that it was infinite. Again, you can't have infinite in expanse because all you're saying is it's growing. It's like a balloon. It's growing, and I guess the expanse is traveling faster than you.
He's saying that the expanse will never end. But
but you never reach the end, because that's why it's infinite for you as an observer, because you never reach the edge.
It would only be infinite for you if you're traveling slower than the universe is growing, and maybe that's what they mean.
Yeah, in other words,
even then, he's talking about distances, which are concepts.
Yeah, what they're doing is kind of cheating, because on the one hand they're saying the expanse, meaning, if it's expanding, right? It's expanding, then at some point conceptually it's got to have an end. But they're saying it's infinite, meaning I'm trying to reach that edge, but the edge, I guess, is growing faster than I can reach it, or whatever. I never make it to the edge, so I'll call that infinite.
Yeah.
But that's traveling. That doesn't have anything to do with
incessant traveling is different than infinite universe.
Right. And it says the thing there's no rule that says something can't be zero mathematically and infinite physically.
What? What is?
So this is how people think or don't.
Zero mathematically.
Yeah, it says it's zero mathematically,
physically.
but it's infinitely physically. And again, this is where the problem is. And he says the critical term is measurable.
Okay.
Can you measure? Which is a mathematical issue. It has nothing to do with physics. In physics, we don't measure anything. Okay, we're observer free. There's no observers, no measurement in physics. In physics, we have to explain how things work, why they work the way they do, what the cause is, what the mechanism is. We don't need any measurement for that, or any equations, or any of that nonsense they have in mathematical physics. Until the universe expanded, right? And matter formed, in other words, matter came out of nowhere, right? The word dimensions had no meaning. Yeah, okay, don't tell me about it. There was nothing to measure and no way to measure it.
Okay.
That doesn't mean nothing existed. Everything existed. So nothing exists.
That doesn't mean nothing existed. Wait, so he's saying before the universe expanded, i.e. had no dimensions, i.e. wasn't there, everything existed.
Yeah.
Everything existed before everything existed.
But at the beginning he says, until the
universe expanded. Matter formed.
Until matter formed. And then he says,
until matter formed.
Everything existed.
Everything. What? It's one or the other.
But people talk like that. All these people, they're unreasonable, irrational individuals, but this is how they portray their theories. This is the way they think. Or could that be called thinking? I think a snail can beat them.
Before the Big Bang, the universe existed, is what he's saying.
Here's another fella. He says the following. He says,
no, it doesn't end.
I'm still saying that the universe is infinite.
Yeah.
By infinite, I mean but never ending. Yeah, he didn't solve the problem there. You will never reach the boundaries of whatever at whatever speed for whatever long duration journey. So he's explaining finiteness or never ending by saying you're traveling. He's going to try to prove it through a trip, through traveling, through a motion. Okay, that's the problem. The problem is they justify infinity with incessant traveling.
But I would say, isn't this just a conceptual issue of taking a snapshot and zooming out?
Right, it should be like that, but these people are they're trying to prove infinity.
And they're saying no matter how much you zoom out in your mind, the space just keeps generating more stars and more stars and more stars.
I'm not really sure how. I don't think they visualize this ever in their life. I think all they're saying is, oh, it's infinite, and they just get rid of the problem. It's like, I'm going to put away from you, and I'll call it infinite. They're not analyzing what they're saying. They don't analyze the words coming out of their mouth because they don't think language is important. And language is
Okay.
absolutely important. You cannot explain finiteness of the universe of a ball by saying, I'm going to travel. Here's the ball, right? The ball is finite. It's got a boundary, right? And you're in the
That's what makes it
center.
a ball.
Right. Let's assume you're in the center of the ball,
Yeah.
and you're trying to travel to the edge, to the boundary, to the surface,
Yeah.
right? And they're saying, the universe is infinite because I can travel forever and never reach the edge. But you're talking about a ball which conceptually already, before you travel, before you do anything, is already a finite ball.
Yeah.
It already has a boundary.
Okay, but
So
then
you don't have to travel. It's conceptually, you're already beaten conceptually.
But then my question to you is, under the rope hypothesis, we understand that the matter in the universe is finite. Even that, I don't like saying that, but you know what I mean.
Yeah,
If you counted it,
if I were to count all the
there would be a
matter,
number.
fixed number or volume.
But then space, the black stuff, the stuff between matter, is that infinite under the rope hypothesis?
And again, it can't be because
Or
concepts cannot be finite or infinite. Concepts cannot be. You cannot use an adjective and say to qualify a thing.
Yeah,
I'm sorry, you use an adjective to qualify a thing, but space is not a thing, and
But
therefore you
that's the
cannot use
weird
an
thing.
adjective and say it's finite, it has ends, it's bounded. You can't use any of those
But
words.
that's the confusing part, because even under the rope hypothesis, if you zoom out and zoom out and zoom out, sure, the matter in the universe goes to a dot and you don't see it anymore.
Yeah.
But you keep zooming out, it's still black. The blackness never ends.
Yeah, but again, you
Which
can't
is
say it
weird.
never ends because it's not a physical object.
That's the
And
confusing
I'm
part.
saying-
There's no space.
But we can unconfuse it.
Yeah.
We can unconflate it by saying, let's just use it for things. And since space is not a thing, you cannot talk about the infinity or the finiteness of space because it's not a thing.
But
you can talk about the finiteness or infiniteness of a table, and hopefully all tables are finite.
But I guess the conceptual challenge of no matter how much you zoom out, there's more nothingness. More nothingness already doesn't make sense, I guess. Maybe let's start there. There isn't more nothingness. You're just zooming out more.
Right, because more nothingness or zooming out just means that space is not a thing, and it's not finite or infinite because it's not a thing. And you cannot use the word finite or infinite.
You can't even say
space.
unbounded because there's nothing there to be unbounded.
What you can say is you can travel incessantly, out of that block of matter.
You could travel incessantly.
Let's say you're God, right? And you can leave the universe.
Okay, that'd be a good question. The
Yeah.
distance that you can separate yourself from the matter in the universe, that
is incessant.
Infinite.
Incessant.
I like infinite because it's a number. The distance, the number. If you had a measuring stick that just never ended, that just kept going, you could pull that for as long as you want.
Yeah, you would have to stretch the ruler.
Yeah, but that doesn't mean that the universe, the blackness, the space is infinite, because all you're saying is the distance between you and the rest of the universe is ever growing.
And that's why I'm saying you have to put it in the right context. You can say that the rod or the ruler extends incessantly. That you can say.
Even that wouldn't happen.
No,
but at some point the ruler runs out.
No, but
it would have to be a magical
let's
ruler.
Magic, right?
Yeah, it's a magic
you stretch the ruler incessantly forever, no problem. Yeah. But then keep it within that context. Yeah. You can't say the ruler is or that space is infinite because the ruler extends incessantly.
Which is
that's the issue. Here you have another fellow, and
another one.
Oh, we have a lot of
the same thing, or no?
Says, where's the Big Bang? And he goes in there and he says it's infinitely big, and we have infinite space, right? This is how he does it, but
infinitely big.
Yeah, but what does he have to do? Well, he's going to curve it around. He says, look, he's going to try to take these three shapes that we have that general relativity proposes: finite ball, infinite saddle, and infinite plane. And he says it curves around. Okay, the infinite plane really curves around, and he's going to do another Stephen Hawking on this. He's going to say, I'm going to roll around that. Okay, but instead of rolling around, he says the following. He says, look. If another possibility, he says, is that the universe is indeed finite. Okay, but this would mean that the cosmos curves back on itself. So he's going to take the flat infinite plane and he's going to curve it around, turn it in he's going to curve it around into some kind of donut.
Like a wheel?
He's going to use a donut, really, right? And he's going to curve it around. This also means it doesn't have a center. What do you mean it doesn't have a center? There I see a center in the middle of that donut.
Yeah.
There's no matter there, but you still have a center, right? As an analogy, and here he explains it, he said, try to point to the center of the Earth's surface. Okay? Like on a map, any point is just as good as any other. In other words, he's saying that if you have a point at the edge of the Earth, he says that point can serve as the center, but any point can serve as the center of that ball or of that donut. Mm-hmm. But see, that's missing the point. The center is what's in the center of the donut, not on the edge of the donut. And that's where, again, they move around. They're comparing apples and oranges. And we're going to talk about the center of the donut. You got to look at that center point right in the center of the donut, not one at the edge. So he makes the wrong conclusion. He says this means that Big Bang happened everywhere throughout the universe simultaneously. Okay,
wow,
the Big Bang was not a point in space; it's a location in time. Okay,
a location in time.
Yeah.
We're already off to a wrong.
Yeah, he changed the subject completely.
No, but location in time.
Yeah, okay.
Where? Up, down?
Well, maybe the clock was there at a given location. But then he says it belongs in the finite past of every entity in the universe. And then he says everywhere is a center. Oh, he fixed the problem there. Everywhere is a center. It's like, saying God is everything. These conclusions from people who call themselves physicists, scientists, these are irrational individuals. They have no place in science. Okay? So what do we propose? Well, we talked about that a little bit the other day. I'm just going to show it very quickly so people have a comparison.
The donut universe.
Yeah, well, here it is. This is the ball universe that we're saying that this is one possibility.
Oh, but let's clarify. With universe, what are we talking about?
Well, we're saying all the matter, right? The black stuff is space. It's not a thing. It's that which doesn't have shape, right? So the black stuff, don't worry about it. We're just saying it's a concept known as nothing, that which doesn't have shape. What has shape are the things that are in the ball. And all these atoms, all these galaxies, stars, planets, they're all in this ball. Okay, that's one possibility, that the universe is some kind of ball, and then what continues after that is what we call space, meaning that which doesn't have shape. That forms the background to every little atom in the universe. Okay, this is the donut-shaped universe here. See if I can see it. Here it goes. That's the donut-shaped universe. Okay, more or less the same thing, but we're going to have it as a donut. Okay, donut-shaped. And so one of the issue is gravity. Why do things get attracted to each other? Why doesn't this whole thing collapse to a point? Why doesn't the stars on the outside or galaxies on the outside go flying out of this? And so for that we use the field. Okay, the magnetic field. We're saying the magnetic field extends way beyond the ball. In this case, okay, that's one example. Okay, again, these are examples for you to ponder. And here's the donut version, okay, of that. Okay, you have the donut and you have the magnetic field of the universe extending way beyond matter. And that keeps or maintains the integrity of the universe. And that's these are things for you to ponder again, So these are our possibilities under the rote model of the universe.
The universe is a donut. Sorry, a torus. Ooh.
Maybe a torus as well. Maybe it has some irregular shape that we can't imagine. But I think you have to put it in that context with the rote model, at least. Okay, let's move on to the subject matter of today, the main course, which is consciousness, subject that my son loves a lot. Let me give you an intro. Oh, hold it. I forgot something here. No. One more thing, because it's got to do with the singularity, okay, of the universe. Okay, so let's go with this one.
What's the singularity of the universe?
I know the singularity. Well, it's where we started. Big Bang was a singularity. Okay, here we have a gentleman. His name is Victor Toth, and he writes a lot in Quora. Okay, he's very popular over there. And he says, there's no single point. Okay, the initial singularity is not part of the universe. It is a moment. Again, time. They're talking about time here. A point is time that does not exist. A point in time that does not exist. Whatever that means. Okay. Only subsequent points in time do. There are points in time arbitrarily close to the singularity. The closer a point is in time the closer a point in time is to the singularity, the denser and hotter the universe is, but still infinite. So he's proposing an infinite universe, but he's saying that you have to get closer to that point in time called the singularity, right? That point where everything started.
Frame zero.
But he explains what he means. He's talking about spatially infinite universe, which he says in several passages there. But this is the important part, what he says here. He says, things that are very far, listen to this, this is so funny. Things that are very far apart today would have been very close in the early universe. Okay. But that does not mean that they originate from a single point.
Doesn't make sense.
No, he explains that. He says, only that they were very close, and no matter how great a distance you name, no matter how early in the history of the universe you go, you will always find things that are farther apart than that distance. In other words, he says, you have all this matter, and it gets closer and closer and closer together, no matter how far you go in the past, in time and in space, right? You can go as far as you want, but you will always find that there's distance between matter. That's what he's saying. So it doesn't converge to a point. There's always distance between any two bits of matter. And that's an irrational statement first. Second, it violates general relativity, which this gentleman supports. And let me show you why. So here we have it, okay? This is what we have. If, as Toth says, no matter how early in the history of the universe you go, you will always find things that are farther apart. This violates the Big Bang Theory, which says that the universe is 13.7 billion years old. He's talking about infinite time here. He's saying that no matter how far you go, there's always going to be distance between two particles. They never meet. They never touch each other. They never form a singularity. No, I don't know why, but that's his argument. And so we have to turn this thing around and see what his reasoning is. His reasoning is, if you look at the picture there, that's the Big Bang exploding. Let's take the movie backwards now, okay? We're going to look at this in reverse. Here's the Big Bang in reverse, okay? Okay, so we're going to go back to the little point, right, at the end, right? And which apparently disappears because it came from somewhere, I guess, right? So this is, he arrives at this point here. You'll see it here. Okay, there's the point. Okay, so he arrived at the point, and the question is, he's saying, if you look at that point, there's still there's still distance between any bit of matter that forms that point. In other words, you're looking at a point from a distance, but if you come in with your microscope, you will see distance between particles in that little point. And so the question is, how did we arrive from nothing to this, to something? Yeah. That's the question.
Well, that's always the question.
And so, and so here's the question. The issue is, like all relativists, Toth is going out of his way to avoid answering the only question he has to answer. And the question is, how did the first bit of matter come into existence? By what mechanism does nothing become something? That's the question he's got to answer. And no relativists can answer that question. They don't want to answer that question. They say it's beyond their understanding or whatever. And this is not a question of understanding. It's a question of visualization. It's a conceptual issue. You should be able to conceptualize whether, imagine somehow how something came out of nothing. And no one can do that. Not even God can explain that to you. Because, you would have to explain the mechanism. There is no mechanism to produce something out of nothing, especially by itself. And it says the answer is that matter is not infinite. That's the answer to Toth's question. It's not infinite in time. If we could go meaning, right? If we could go eternally into the past, we would always find matter. No, you cannot say that if you go back in time at some point you find no matter. Okay, you always will find matter. Why? Because in the case of the rope model, there was no creation of matter. In the case of general relativity and quantum mechanics, quantum mechanics does create particles out of the void, so they do like that idea of creating something out of nothing. They never explain how. They just say the particles make up space, form space, they are space, and the particle is just coming in from space and making itself visible or whatever, detectable for a brief moment in time, called a virtual particle, and then goes back to being part of space, whatever that means, right? And so the question is, these people are trying to avoid the question. And the question is, how did matter come into existence? And so the answer is matter had no beginning. The Big Bang never happened because Big Bang is a creationist theory. They try to avoid looking at the first frame of the film. They always start at the second frame of the film, and they're saying there was always something there. We don't know what happened on the first frame where there was nothing. So that's essentially what they're saying. They're avoiding the question. The answer is matter has always been there and there was no Big Bang. Not even Almighty God can explain how nothing morphed into something. That's the answer to the question. And that's the question relativists try to avoid because they can't answer that question. So they try to say that it's an irrational question, that we can answer it, we have no way of proving it, we have no experiment we can run. They go through all this rigmarole. They always tell you that they don't know what's outside of the universe, that it's an irrational question because we can't prove it with an experiment. All that is nonsense. All that are irrational answers. The answer is matter has always been there. Then we can make sense of this universe. But if you try to ask how did matter come into existence, you cannot answer the question because the ball is in your court. You have to tell us by what mechanism something came out of nothing. And not even God.
Well, that would just be an axiom at that point. You'd have to accept that something can come from nothing. And once you accept that, you can accept anything.
Right, but in physics, you have to explain the mechanism. If you can't explain the mechanism,
that's what I mean.
It's an axiom that
it's
you have
an
to...
axiom.
Yeah, it's an axiom, but then it's an irrational axiom because you're just saying that because you just want to win the debate or whatever.
There's no such thing as an irrational axiom. It's dumb.
Yeah, but you cannot. Right, it's very hard to concede such an assumption.
Well, the problem with that
let us assume something came out of nothing. It's a big assumption.
But if you can concede that something can come from nothing and vice versa, then you can explain everything with magic. You say, "Oh, God came in, made it, and then left."
Yeah.
Well, where's the evidence? Well, He can come in and out willingly anyway. So
much simpler to say matter has always been there, and every atom has always been there, and the universe is eternal in both directions of time. If you want to use that term,
if you like time,
and we're done. Yeah, it's infinite.
yeah. Oh God.
Okay, so all I can tell you is these are my conclusions. And again, I'm not going to watch for Hans here, but conclusions. Mathematical physics uses adjectives to qualify motion. Let me put it in the center here. There we go. Infinite, unbound, incessant. Infinite, unbound should be used as adjectives for objects and incessant, perpetual for motion. That's all I'm saying there. Infinite space is irrational because, why? Because space is not a thing. It's not an object, not a body. Something is that which has shape. Nothing is that which doesn't, right? And now we can use these words consistently. And nothing cannot morph into something. Matter has always been there. It's had no beginning. It's always been there forever and ever in both directions of time, if you want to call that like that. And the amount of matter in the universe is fixed.
In my conclusion, what I would say is the word infinite and finite only apply to numbers, so you can't even say space is infinite because that's not a number. The number of tables are finite. You can't say the table is finite.
Well, I'm
the
saying
number of tables are infinite. You can't say the tables are infinite.
Okay, I'm saying it's the other way around.
I'm saying you can't say space is finite or infinite because space isn't a number.
Well, again, all I'm saying is let's use the word, and here we will not see eye to eye. I'm saying the word finite was introduced from ordinary speech into physics, into from mathematics into physics, and it refers to non-objects. And so they talk about infinite counting, meaning incessant counting, when finite should really be used for object. But we can make a convention and say, let's just use the word finite, end, like endless, etc., bound, and limit, like limitless, etc. Let's use those words for objects, and use words such as incessant, eternal, eternal, perpetual. Let's use those for constant, let's use those for motion. And as long as we keep motion and objects separate, we're going to make sense. We're going to understand the presenter. If we mix them and talk about finite, unbounded, well, then we made a mess of the whole language.